Okay, and just a second, we will go
Guys,
live now.
can we start? Venkatraman, is it okay?
We are live now.
Hey, Venkatraman, are you there?
Okay, I think we can start now. So today is day 13, the hands-on project 2. So I am Karthik Sainath Reddy from third year, core team member of Robotics Club Sastra. So today's session, Ravi Anna, Raviteja Anna and Yashwant Anna are going to handle. So please be attentive and interactive. We are ready to solve your doubts in the chat room.
Yeah, if we are ready to start, everyone please give a thumbs up so we can go on. Raise your hands. Guys, if you are ready to go, just raise your hand or some sign that we may take. We will start.
I think everyone is ready.
Okay. Should we wait for your friends, guys, or can we go? Just respond.
Yes, try to be interactive so that we can share more. If you guys are not being interactive, then we'll also get bored to teach. Karthik,
Anna.
is there option for them to turn on the mic and talk?
Yeah, they have option, I think.
Okay,
Guys,
so
someone from audience,
can I hear some voices?
there is a condition here. If I am going to say something, I want at least one of you to open your mic and answer. I won't see chat. Let's see how many of you will do this. Okay, I guess we can start. At least for this, I want an answer from Mike, not from chat.
We are going to start this session if we hear some voices, or else the session will be like this.
Okay, now we can start.
May I know your name?
Raguraman.
Okay, Raghuram. Only Raghuram wants to start. Any more?
Hello.
Guys, I'm thinking everyone is keeping their headset and just roaming with the mobile here and there.
Can you hear me?
Okay, then we can begin, I guess.
Okay, you can start, Ravi.
Yeah, so hello everyone. If you guys missed the fireside chat, my name is Raviteja and I'm from 4th year mechanical engineering from Sastra University. So basically, my interest is towards robotic stuff related to designing and also related to embedded systems, and my most of the part is contributed towards designing and simulations. So I guess our team have delivered the content respect to design. So do you people know some softwares where you can simulate the designs, like whatever you have designed, if you want to analysis them? Do you people know any softwares for that? Open your mic and say the answer. Don't keep the answers in chat. Make it fast, guys. If you know, just open your mic and say yes, or else say no, no problem.
Yes.
Okay, what is that software? Hello, Raghuram, you only I think answered, right?
Guys, we are not going to scold anyone. All wrong answers are welcome.
Like
Please
we are also students. We are not faculty. You can interact with us. I
and
guess
we don't
what?
have your sim marks or something.
Yeah, we are not from any other college. Also, I guess so many of you are from Sastra only. If you are from other college, also you can interact. It's not like only Sastrates can open their mic and talk. Everyone is having that option. At least one software I can hear. If you say like I can continue. If you say one name, at least I know. Okay, these people are having some knowledge. Okay, with this silence means I can presume that no one knows any simulation softwares. Okay, I will ask a question. How many of you know about Copelius? Yes, not only LinkedIn posts, interaction also counts here. So be interactive.
MATLAB.
What was that?
Someone said MATLAB, I guess. Who is that?
Okay.
Raghuram.
Okay, okay.
Raghuram.
Yeah, so you MATLAB.
So Ravi, let's start addressing by names from now on. Okay, Karthikeyan. I see there's a Karthikeyan S in the meet. Can I hear your voice? This is the last day, man. I think tomorrow we have a day, but today is hands on. So I want to hear voices.
It's going to be very interesting. So please, try to open your mic and talk. It will help you to interact, guys. Just open your mic.
Haranya Krishna. You're leaving, guys. If I'm speaking your names, you're leaving, right?
I think these people are cultivated to online classes. While faculty calls their name, they are going out.
And Anna, just a
Okay.
second. Guys,
Okay.
attendees, are you able to open your mic or is there anything blocking? I would like to know. Some of the attendees try to open your mic and say something to verify that you have mic option.
అన్మ్యూట్ లేదంటారా కార్తిక్
I think Raghuram is answering sometimes. I guess it's available.
Raghuram, can you unmute and speak something? Yeah, they're able to unmute.
Karthikeyan, this is the problem. Okay.
Yeah. So except program, can anyone give it a try? Unmuting yourself and speaking something or say hi to us.
Raja Ganesh, can you unmute once? Okay.
Hi.
I think it's working.
Yeah, it is working.
Okay, anyone more? Okay, there are guests, right? Karthik,
No.
make them attendees.
No, all our attendees, only we four people are presenters.
No, the guests. What are those guest roles?
Yeah,
Maybe
only
they have joined without any mail ID.
Yeah.
Without any login. So it will mark as guest.
Yes.
Okay, anyone others than Raja Ganesh and Raghuram, are you able to speak? I want to hear some Majita Sharon, Siren, sorry if I'm wrong. Udaya Kumar. Anyone?
Yes,
Name,
Thank
please.
you.
Abhijit. Okay. So start. Sorry, you can start.
Yeah, so there is a software known as Copilot Sim. It's like an open source simulation software, and it will contain a physics engine. So physics in the sense it's nothing but it includes gravity, it includes different types of features to analyze the components which we are designing, and to know their mechanism we can use that. Actually, people have learned so many things with respect to kinematics, right? Like joints and all. So you can find them in that, and it's open source, guys. It's totally free. You can utilize it. So today I'm going to just introduce, and I will give a way for you to how to use the Copilot so that you should explore more. Like everything is available in internet. Copilot is having a separate documentation where you can get to know about different features of it. So I will be just making you just introduce that software. Okay, my screen is visible, right?
Uh,
Okay, so basically, this is the Copilot software user interface. Like immediately when you open the software, you will be seeing this. And if you want to see this parallelly, I will share the link of this download. You can download it, but it will take time, like around 170 MB. It's there. I will paste this in the chat so that you can save the link. So basically, this is developed by Copilot Robotics, and in that, this is the UI. When you open the software, you will be seeing this. And coming to first of all, I will just make you understand what are the commands available in this software. So this is called as scene. Scene in the sense nothing but the place where we'll be keeping our objects or our parts and we'll be simulating them. So you can see this is the floor. So on that floor, we'll be placing our objects and we'll be doing the simulations. And here you can see that on the top right corner we'll be finding the menu options. So here 5 options are there. In this you can find new scene, and you can open the recent scene, and you can save the scene, and you can save the scene as a model. So different options are available. And next one is edit. Once the object is selected, we can use this edit option. Like different options are there. And this is the important part of Copilot where you'll be able to add the primitive shapes, joints, camera, light, dummies. Like these are all different objects of Copilot, like features of Copilot. So primitive shapes in the sense everyone will know, like plane, disc, cuboid, sphere, cylinder. Like these are some shapes which we'll be using in real life. Like these are pure shapes. And coming to joints, I guess you have learned about this in the kinematics part, the value joint and prismatic and spherical joint. And simulation, like after this camera, like there are camera, suppose you want to take the pictures of the simulation or you want to use the pictures for any purpose, you will use these cameras for that purpose, like vision sensors. Basically there is another type of vision sensors. And lights in the sense nothing but floodlights, like you'll be using lights to glow that scenery, like scene. And these are dummies. I will say what are all these in few minutes. And next one is graphs. Suppose you want to analyze the motion of the object with respect to graph by plotting the time versus speed or speed versus displacement. You can utilize graphs. And there are sensors also, proximity sensors, vision sensors, and force sensors are nothing but it will help you to hold an object. Like it will be, suppose you are holding your hands together, you will hold your hands by closing your hands, right? So like you'll apply a force there. So normally in simulations you can't generate a real-time force, so we'll be using the force sensor to make a connection between two different objects. And also we can measure the force between the two different parts when they are in motion or when they are in steady state. So these are all different features of this. And coming to simulation, just it's like normal. When we are completed with our setup, we can just click start simulation. So the simulation will begin. And tools, these and all are just random things. So there are different modules also. Suppose you want to install something with respect to Python, or you want to do something with respect to collisions and all. There are different modules available in Copilot. Like latest Copilot has this type of features. In old Copilot we don't have all these features. So basically Copilot provides a wonderful user manual. So in the if you click help and go to user manual, you can find everything related to Copilot. They have given all whatever you want, they have mentioned there. Like suppose you are just a beginner, you don't know what is Copilot, you can learn from this part. So here you can get the different like descriptions of each and every topic in population. Okay, so you can go and explore this. And coming to next part, you'll be having the command bars. Command bars in nothing but suppose this is camera pan. Camera pan is nothing but it's allowed to move your scene in x and y axis. Suppose see I'm just clicking on the scene and I'm trying to move this. So camera pan is used for that option. Just moving your object in x and y directions. And next one is camera rotate. Like suppose I have a camera, I want to rotate that. I'll just click that option and try to rotate that. The camera will be rotated on the floor. The next one is zoom. So just I will be clicking that option and I will be dragging it. It will zoom in and zoom out. So this is one of the option. And next one is camera opening angle. Like whenever you want to set the camera angle, you can use that option. And this is nothing but fit to view. Suppose I am adding one object. I'll show you how to use that. I'm adding a primitive shape named as cuboid. So I'm keeping the default size. Okay, in Copilasim everything will be in meters. Just remember this. See here they have mentioned meter. The meter is the unit which will be used in Copilasim. Like you can't change that unit, so you should convert everything into meters while using. So I have added cuboid here. So you can see that this is cuboid shape. And now I want to fit that to the view. Means fit to view means it will go near to that object and fit to that isometric view. So that is the use of fit to view. And these are like selecting, like click to selection. Normally I'll use that option for selecting an object. Next one is object item shift. Suppose I said right, this is used for moving the floor, but this will be used for moving the object on the floor. See, I have selected that option and I am trying to move it in x and y axis on the floor. So the floor will be constant and this object will be moved from one place to another place. And you can set that axis. Suppose I want to move it along the z axis only, I can move it along the z axis. Suppose I want to move it in x and z, y and z axis, I can select that also. Like in Copilasim, at a time you can either move in one axis or you can move using two axes. Three axis can't be used. And also you can select the step size. Step size is nothing but for the point of like displacement units. I want to move that by 0.001 meters. Means every time I just move, it will move by 0.001 meter. That is the use. And position is nothing but the coordinates of this. It will be in population coordinates. So x, y, z values. Like if you keep this cuboid in a 3D plane, you can find the x-axis, y-axis, z-axis value, right? That is the coordinates actually. That is not the length or breadth of this cuboid. Translation is like if I want to translate using manually, like I will give some value here 0.001. I will click X translate. It will move in X direction like that. So these are the options for translating. This is for rotation. Like this option you can see object item rotate. So nothing but just rotating about it axis. I selected X axis. In this rotation only we can select one axis at a time. About Y axis I can rotate it. About X axis I can rotate it. So this is the basic use of this rotation. Orientation in the sense this will give the present orientation of that object. Rotation means, as I said, similar translation, I can rotate it with respect to degrees manually. So I can rotate it with respect to degrees. So these are the basic features of this. And this is undo, everyone will know this option. And this is redo. So these are like normal dynamic. If I want to go in deep to this, you will be confused because this is just a basic session, intro session. So I won't go in deep. If you want to explore this, this is the best software you can use for simulations with respect to like normal. Like if you have designed something in SolidWorks or Fusion 360, you can import them here and you can use them for simulations. Like basic analysis can be done. It's not very high-end software, but it can be equal to high-end softwares. So this is nothing but the physics engine which is used, like dynamics engine. Bullet, there are different engines, you can use whatever you want. But before using, just explore their usage. Next one is whatever performance or something like that. So we can say dynamics, how it should be. It should be very accurate or balanced or fast or very fast, we can select. And this is time, like every second how much time it should use, like time change is 50 milliseconds. Similarly, you can set this to more and you can set this to less, but defaultly 50 is suggested. Next, this is play button. This is nothing but just starting the simulation. This is pause, this is end. See, this is just an object I have placed. I haven't set any properties for that. If I just click plus, like start simulation, it will just fall on the floor because it's under gravity. You know gravity, right? It pulls the objects to the floor, ground. So similarly, it is like falling under gravity. That's all. I haven't set the objects. So next one is everyone clear with this up to this point? Guys, is everyone clear? At least one, open your mic and say. Is that interesting or boring? One minute, guys. Okay, so only Venkatraman is clear. Others are not having any clarity about this.
Yes, bro.
Okay, sorry guys, I'm speaking. So this is the simulation related settings, and coming to model browser, these are all the different examples given. So we can explore these examples. These are given basically to make you understand how Pupilasim is utilized. So you can just go to this, open this and just drag and drop it, and you can just click the simulation button. If you want to understand how that is working, you will find a script here. See, this is the script symbol you can find. Hope I am audible now. So if I
Yeah,
double click
you're
this,
on.
yeah, so here you can find script. Don't worry about this and all, because if you are like really new to this, you will not understand anything. You can just go to Copilot documentation, read everything and then come to this and see, you will understand it. Okay. So non-mobile in the sense they are just like they are placed in that position. They can't be moved from one position to another position. So those are called non-mobile bots. So basically these are all like very advanced bots. So I think you can't explore this at the start. So go with some basic bots and explore. Okay, don't go to see. You can utilize this arms industrial manipulators. So you can use these and you can explore how they are working. So these are basically very useful things. I guess our people have said you about this. See how the arm working. So these are all are there for you to explore. Vehicles are also available, like helicopter. So these are the different like different types of vehicles are also available. These are just to explore. If you want, you can utilize in your project. Suppose you are doing a project and you want to use a helicopter in that project. No need to build a helicopter. Population will give that by default. You can utilize it and you can link it to your project. That is the way you should do. And these are the layers. And next one is scene hierarchy. Hierarchy is nothing but normally hierarchy in our family is like father, mother, and child and grandfather, grandmother. This is known as hierarchy, right? Similarly, in this also, Kopila sim, if you want to connect two objects, they should be perfectly in a hierarchy. Means, suppose I will show how to add object and I will show different how to use different joints. So first of all, before explaining the hierarchy, I will show you how to add two objects and how to simulate them. Just a basic example, and later that you can go and explore. So first of all, just go to add option and select primitive shape. First of all, I will add cylinder and I will not change anything. Okay, so just I will click the default size and I will place it and I will click option. So now what I should do, I have created one object. If I want to simulate this, suppose I want to use a revolute joint, I need another object, right? It should be like rotating on this cylinder. So now I will add another shape known as cuboid. I will not change anything. I'll just keep same size. If you want to move any object, first you should select that in the hierarchy and then click your respective option. So I will translate along z-axis. So I have translated it to a certain height. And now what I will do, my aim is to rotate this cuboid by keeping the cylinder as the base and it should be steady. Like cylinder should not move, only this should rotate. So do you have any idea on how to do that? Like any idea, like general idea, no need of population idea, normal idea. Do you have any idea on that? How to do that? I should rotate that cuboid on the cylinder by keeping the cylinder static, like it should not move, and the cuboid should rotate on the cylinder. How can I do that? Any idea? At least like the basic idea, no need of all the things. Just give me basic idea if anyone knows. Just give a try. No problem if it's wrong also. I am here to correct. Okay. Just to be interactive guys so that I can get some energy and I can explain more. If you are not interacting, I will leave it. I said right, let it be round. Just open your mic and say something. Any idea how to rotate? You have learned this actually. You have learned about the joints, I guess. Rahul, I guess joints were taught, right?
Yeah, bro.
Yeah, so
We
you have
already
learned
covered.
about joints. At least you should have got an idea on that, like what I should do there. Participants, anyone?
Just give a try, guys. Just give a try. It's
Just give it a try.
right or wrong.
Like,
Doesn't matter.
see,
Just give it.
uh, not only here, guys, when you are going outside, like when you are coming to placements or when you are going to another places where people are there, you should be able to interact with them. You should not sit silent. Like, it will be like you can't get into good places where if you are not interactive. Okay, so try to be interactive. Just first make that fear go out from you. Just turn on the mic and talk. That's not a problem. Initially, we used to be very scary to talk, but slowly we used to talk. So you can also start like that. Maybe this summer school is a platform for you to talk. You can open your mic and say any idea. Let it be wrong, no problem. Rotatory motor. Okay. Any other answers? Only Venkat is the guest here. Remaining people are like silent. I don't know why. Okay, if you are like willing to be silent, at least put it in chart so that I can know you guys have learned something in this summer school. Make it fast so that I can know. I will explain this and I will stop because Ashwin will take another part. Only Venkatraman understood the summer school part, like 14 days is helpful for him only. What about others? Okay, I got a perfect answer. It's revolutionary joint. So good, Venkat. Sorry, Uday Kumar. Yeah, so I'll add a revolute joint. I said, right, copulation is having a feature to add revolute joint. So I will add a revolute joint now. Just click add joint in that revolute joint. Now what I should do, I should place this revolute joint in between this. So I'll just move that revolute joint along the z-axis. Okay. So basically now the revolute joint is placed, and now we should set the properties. Normally in any object you will have two properties: dynamic properties, static properties. Static in the sense, what is static? Anyone? At least put in chat what is static. Is anyone there? What is meant by static and what is meant by dynamic? You can answer in chat also if you are willing to be silent. Static and dynamic. Like you need not be a mechanical guy to answer this question. It's a general question, okay? Dynamic is in motion, static is in rest. Okay, yeah, it's correct actually. So static means I said right, this should be static and this should be dynamic. So now to set the properties, first of all select cylinder. Here you can see the icon, right? Double click on that icon. Now you will get a scene object properties window. In that set the dynamic properties. So in that I'll just click everything turned off. So my cylinder is now static. If I click this, it is dynamic. Means it will respond to the friction, like friction, what I can say, gravitational force, everything it will respond. If I click this option, like turn off this option, now it's static. So I want that only. So I just keep it static. And this is normally in defaultly every object if you add it will be in dynamic only. So no need to touch that cuboid. And now what I should do, this revolute joint should act as a motor, like it should rotate, right? So I will double click on that. Same again, show dynamic properties, and in that control mode. So control mode in the sense whether it should be like just as a joint, or it should act as some force sensor, or it should have some velocity, or it should be rotated through some angle. So you can use the revolute joint as servo motor also by just setting some position. Okay, now I am just setting velocity so that it will move with some velocity and it is having some torque in that. So now I just click that all the all the properties are set. So first of all I will try to simulate. Let's observe what it will do. What happened? It fall right. Like I said, you can find exclamatory mark. See, observe one thing. If you are using revolute joint, it should be in a hierarchy. I said right, father, mother, child. So here father is cylinder and mother is revolute joint. So now the child is cuboid here. So just drag it and drop it under the revolute joint. So now the hierarchy is set. Like you should set hierarchy so that now cylinder is connected to revolute joint and revolute joint is connected to cuboid. Now if I simulate what it will do. See, you can see that the cuboid is rotating. Okay, so this is the beauty of Copilasim. I can say, like in simple words, I explained. Okay, I have done some big projects, but I can't show them here because they are copyright. That's why I just showed a simple arrangement of cylinder and a cuboid. So I can set the properties. Okay, I'll show. Revolute joint, show dynamic properties. This velocity is high, right? I can set it to small velocity also, and I will start simulation. See, it's like moving with a very less velocity, like degrees per second. Velocity in degrees per second because it's a revolute joint. It should be in degrees per second only. And suppose I want it to be faster and keep some 100. Okay. If you want more faster means you can keep it more faster also. Like you can change the properties. Okay. So this is basically the usage of revolute joint. So I just explained revolute joint properties for you. Similarly, you can utilize, like you can explore about prismatic joint also. Okay, so this is just a basic overview about coalescing guys, and if you want to explore more about this, I said right, just click help user manual. That's what I too did before starting this coalescing. Like you will find very interesting because it's open source, no need to pay money. You should download education version. Okay, wait, I will show. In this downloads, you will have player education and pro. So you make utilize of education because they provide everything in this when you are in a college and university. No need of any details also. Just download education version and start working with it. Like programming is a little bit difficult actually. First, you should learn Lua programming for this, and you have resources for Lua also. And then you should start like nothing else. You should have some interest to learn. That's all what I can say. Nothing more than that. If you have interest, you can learn it. That's all. So, is this okay or not that good? Like population part. Hello. At least now open your mic and say, is the population part okay or not good?
Okay, bro.
Yes, bro. It's good.
Okay. So what about others? At least put it in chat if you are unable to open your mic. Like you can start exploring about it. Just start to design something. Like nothing. No need to be a mechanical engineer. Okay. You can, if you are in CSC also, if you are interested in doing this stuff, you can do. It's not a problem. No one will judge you or scold you for doing that. It's just an interest that should come from you to do. Yeah, so just I gave an overview because it's like if I want to take a session on Copilot Sim, it will take nearly 1 day. Okay, so I just gave an overview. If possible, soon we'll like in after reopening, we'll host a session on Copilot Sim separately in college, like off campus. So at that time you can join. So that's all from my side. Next one you can continue.
Okay. Was it nice? Like, was anyone intrigued by it? Anyone interested in doing some design? Hey, put your hands up, guys. I'm not gonna continue like Ravi if your hands are not up. Okay, Venkatraman, rest of the guys, are you sleeping or you just kept your mobile somewhere and just
See,
daydreaming?
like don't attend the summer school for certificate, guys. This certificates like
It's
if they
nothing.
ask, yeah, if they ask you about what you have learned, you should be able to say something or explain something. Okay, so if you are coming here for certificates and just keeping them like meet on and go away means it's not that useful.
Okay, guys, would you want me to tell you something or would you be this inactive and doesn't want to learn? If everyone is like this, if I won't get at least out of five or six responses, we can end the session. Should
What
you want?
about girls?
Do you
Everyone
want
is
me to
silent.
continue the session or can I close it? And today is the last technical part day where I thought of telling you a few projects. But if I'm not going to get at least six responses from you guys, we can end the session.
Only boys are listening. What about girls? Everyone is silent.
Guys, just let me know. Do you want me to continue or let's wrap up? At least five responses, five chat messages are enough. At least five hands up or something like that. I got only four responses. Where are the and those guys? Okay. So, should we wrap up? Ravi, what do you tell?
Like if it's like this means you can like stop with populism method of making something interesting, but these people are totally inactive.
Yeah, I thought of getting a hands-on project with you guys. If anyone is interested, you can just tell that. So you can just, I'll make you a presenter, and you can open Tinkercad, and I'll guide you through to make a simple Arduino code hosted work. If anyone is interested, you can just let me know. I need a volunteer for the session because it's going to be hands-on, and it's too boring when we are just communicating and you're doing something. Any responses? Any volunteers up? Okay, Himanshu, you can open Tinkercad. Okay, who wants to be the first one? Just let me know now. I'll just share my screen. Just someone type that fast. Fastest fingers first. Just tell that I'll share my screen so we can see your screen. Like we just want to see your open Tinkercad, and I'll just guide you through few things where you can do the original work. Anyone up for the interactive part?
Like, is the Tinkercad taught before or this is the first time in summer school?
I think Tinkercad basics were introduced, right, guys? If not introduced, also I'll start from scratch.
I guess introduced him.
Yeah.
Okay. Vendika said.
So, guys, let me know who wants to share their screen. So I'll make them presenter.
Anyone, like it's like just an exercise, guys. You can like we'll
Just
guide
an
you, you can do
exercise.
it. That's all.
I'll
We
help
won't
out.
put any marks for this. Don't worry.
Oh, no one is interested at all. Okay, Venkatraman. Okay.
Good,
Okay. Karthik,
Anna,
make him presenter.
the name
Venkatraman J.
J Venkatraman. Okay, just a second. Yeah, Venkatraman is a presenter now.
Venkatraman, just share your Tinkercad screen. Like, just share your screen and open Tinkercad in your website. I'll just guide you. Don't need to worry or don't need to get tense. I'm here for you. Everyone, just observe what he's doing. Venkatraman, if possible, you can. No, it's not visible. Is there any problem, Venkatraman?
I think he's having a problem in presenting.
Okay, so Venkatraman is having trouble, I guess. No, you're not visible. Anyone others? You can try it out. Just try to present your screen. Or who will be next?
If anyone want to try presenting your screen, once say your name, I will make you as a presenter.
Yeah, just let me know. If possible, Venkatraman, try again.
No, it's not visible.
It's not visible. Just when you touch you present your screen, just type that and select your screen, the whole entire screen in that, and just share it. Is my
Venkatraman,
screen
I
visible?
think you are selecting a window actually. So don't go for the window option. Try selecting the complete screen instead of a window.
Karthik, is my screen visible?
Na? Uh,
My screen.
for me, no screen and video are visible, but just a second, I'll check it in YouTube.
No. Only Ravi Anna's like his video is visible. No screen is visible.
If you are presenting your screen, video will be stopped actually. So
Yeah. If you're
it's
presenting
not.
video will be stopped, but other than Ravi Anna's video, no other screen is visible. Yeah, now
Yeah, I don't know
My
who's
screen.
Venkatraman. Yeah, Venkatraman's screen is visible.
Yeah, that's Venkatraman's screen.
Yes, I guess you can guide it.
It's not visible in my lab. I'll just refresh it.
Once refresh, rejoin.
Is Venkatraman's screen visible to everyone?
Yeah, it's visible now.
yeah, no, it's visible.
Okay. Go for the circuits, Venkatraman. Press yeah. Just press create a new circuit. Now I'll guide you through. Just take that Arduino Uno board available in the toolbox. You just place it there. Now, what do you do in the Arduino when you get a controller board in the hardware? What do you check first? Whether the board is working or not. For that, we use a simple blink code. So to do that, we just go for code section here, available beside the start simulation button. Yeah, remove the blocks, make it text, continue. And now just flash this. Just press start simulation. Everyone is seeing that an LED is blinking, right? Guys, is it visible?
Yeah, it's visible. What about others? Like participants?
Okay,
Is it visible?
now let us try out with something different. Venkatraman, stop simulation. Close the text post. Text. No, yeah, close the float box. And just take an LED. In the search, press LED. Yeah, just take an LED. Just place it somewhere on the screen. Yeah. Now select the positive end of the LED. How do you know what is the positive end? The longest end would be the positive. Here, what is an anode? Anode is positive or cathode is positive, guys? Let me know. Guys, simple question. 12th physics. Anode is positive or cathode is positive? Okay, connect the positive side to digital pin, any one digital pin. Okay, yeah, that's correct. One digital pin, 1, 2, 3, or anything, whatever you want. Okay. So now where do we connect the ground cathode to? Any answers? Guys, any answers? Okay, ground. make it ground. Nice. I can see responses. Venkatraman, you can connect the cathode to the ground. Touch the cathode, the negative side, drag it down. Okay, first delete that wire. Select the wire, press delete in your okay. Yeah. Now select the anode. No, don't go like that. Go in such a way that it doesn't touch the anode. Sorry, it doesn't touch the cathode. That's better. Yeah, any pin is fine. Now take the cathode and drag it down to ground. Nice. Now to start blinking this LED, go to code. I want someone to answer me. How do we define a pin? Arduino pin. I think Arduino was taught, right? Basics. I think everyone was taught with the basics, right? If no, just respond no. Krishna, Kumar, Avantika, anyone, just
No,
let me
Arduino
know.
is taught on previously. Dheeraj and Manindra handled the session.
Okay. So just change something in the code. Guide your friend Venkatraman to change something in the code such that the outside LED should blink. Its outside LED should blink. I'll be giving you around. Okay. Okay. Oh, good. Venkatraman
has said something silly that.
Okay, nice. Venkatraman, type in the second line. Go to the second line. Oh yeah. Hashtag define. What will be the next word? Anyone? Any answers, guys? I'm waiting for you. Venkatraman is seriously waiting. Hashtag define LED. Now, what will be the syntax? Okay, just let me know how do you define this. So no, D13, no, I think it's just 2, no? I think it is connected to 2. Positive is connected to 2. Just let know. Just to let you know. Just press hashtag define LED 2. LED space 2. Now change LED built into LEDs. Now start simulation. What is that question mark there? Can anyone answer? Venkatraman, just point out to that exclamatory mark which is showing there. What is it telling, guys? It is telling that the current required by the LED is more than what is provided to it. Sorry, it's less. The current required, yeah. Venkatraman, connect a resistor to the positive end. First, delete the green wire. Sorry, stop simulation. First, stop the simulation. Delete the positive anode wire. Now, in the toolbox, search for a resistor. Yeah, there's a resistor in the first. Yeah, connect that to the positive end of that anode. One side of the resistor to the positive end of the anode. Now the other side to 2. Now again start the simulation.
Yeah, it's only 1 minute. So, Avantika asked
So-
for to explain that LED part. It's nothing but a syntax. Okay, so as define is to define a pin, and the variable name is like I'm naming that LED pin as some name like LED here, and space you should give the pin number directly. No need of D like all these things. So here we have connected the to 2. So as defined LED space 2 means the 2 pin number is now reflecting LED. So you can use that LED wherever you want, or else you can directly place 2 inside that pin mode function. Pin mode 2 comma output, digital write 2 comma high. So it's easy. Like it's suppose this is single LED, right? You can use like directly. But if you are using more than one LED or more than one component, then variables are suggested. Okay, so you can use variables there. Both are correct actually, not like that. LED is also correct and this is also correct. That's just like this is simple one. If you are going into complex circuits, then variables are suggested. Don't directly keep that. No need of hash defined to wrong. Like you should not declare any
Error.
definitions if you are using directly. Remove that line.
Leave it.
Number 2.
You can run it now.
So like simple circuits directly you can give, but suppose you are using some 10 sensors and you want to name them, then it will be good to use definitions. Okay. Hope Avanthika's doubt is cleared.
Okay, Venkatraman, thanks for that. So now you can just stop sharing your screen. I think it's already past the session time. Yeah, if you want any other one, I'll just have a last one, where I'll just show you how to interface a ultrasonic sensor. Well, just a second, guys.
Guys, sorry, like I want to leave, so I have given my contacts in the chat. If you want to know more about Copperlessing, or if you want to explore something, you can ping me.
Ravi, is it visible?
Yeah, it's visible, Ram.
My screen is visible, right?
Yeah, visible.
Yeah, guys, see, this is my Tinkercad space. what I do is I'll just take an Arduino board. This is a just normal Arduino Uno board. For this, I just take an ultrasonic sensor. Here I'll try ultrasonic sensor, ultrasonic, and I get a yeah. I get an ultrasonic sensor. It has 4 pins. See, there's a VCC, trigger pin, echo pin, and ground. What this VCC pin does is, it's a power supply to this pin. What this trigger pin is, ultrasonic sensor, what it does, I think a guy told the basics. Can anyone just put it up in the chat? What does the ultrasonic sensor do? Guys, anyone? Yeah, a typical ultrasonic sensor uses simple sonar technology, that is sending waves and receiving it back, sending ultrasonic signals and receiving them back. So here I'm going to show you the connections faster because there's a time constraint. So first I'll connect the VCC to 5 volt supply. This ultrasonic sensor works with 5 volt. So I'll just connect it to 5 volt and the ground to the ground. So now what I do is I take 2 pins, trigger and echo pins. What I do is I'll take this trigger and echo pins and I'll connect them to any 2. For the trigger pin, I'm connecting it to 5. And the echo pin, I'm connecting it to, let us say 6. So this is what, how I connected things. A bit messy, I know. Anyway, fine. So this is the connection for an ultrasonic sensor. So I'll just have some code here. This is some code which I wrote. Apparently, for the trigger pin, what we connected is, it's a 5 pin for the trigger. So I change my code to 5. And here I change my code to 6. See, I'll just explain you what this code does is. Here I'm declaring first the pins which I'm connecting, the echo pin and trigger pin. What echo pin does is, exactly I'll tell you that echo pin is taking the input of the echo. What we do is, through the trigger pin, we send few sonar waves, that is some ultrasonic waves, which on reflecting with some object, they reflect back. After reflecting back, they are to be received by the ultrasonic sensor. So the receiver produces echo pin as an input. What this echo pin is, the difference between the time taken for the trigger pin to produce output and the time we received it. Like there's a time gap, right? We produce at 1 second, 0 seconds, we produce the trigger pin. That is, at 0 seconds, we produce the sonar waves. The sonar waves go and reflect back and are collected by the echo pin after a time after 10 seconds, like that. So what do we know here? We know that it took 10 seconds for the wave to hit the obstacle and come back. So as we know, the ultrasonic sensors travel at a speed of light. So here we calculate that calculate the speed. That is, duration is nothing but the time taken for the echo pin to receive the input after the trigger pin sending the output. So 0.034 is the value, the speed of that is 343 meter per second in sound. Sorry, the the speed of sound in air, that is 342 meter per second. Here we take it in 2 less, I think so. So here this is a maths equation. Here we divide it by 2 because it goes and comes back. So the time into distance traveled gives the time into the speed taken gives out the distance traveled by the distance of the obstacle which is in front of us. Basically what here it does is, here first we send a trigger pin. What a trigger pin to low. So first this trigger pin is low. After that, what happens is we take a 2 seconds of delay. After taking 2 seconds of delay, we produce an output of trigger pin high for 10 seconds. That is, a 10-second wave is produced by the ultrasonic sensor. This sensor, after sending the signal for 10 seconds, it is set to low. That is, it is stopped. And now we already sent a signal, so we need to receive it back. For receiving it, we use the pulse in function and use the echo pin high. That is, we make the echo pin high. That is receiving, make it active so that it starts receiving the pulse, which is sent out through the trigger pin. Here, duration is given. That is, this pulse function takes the input and measures how much time it took for it to return back from the trigger pin. From the trigger pin, we send an frequency wave which gets reflected back and received by the echo pin. This total duration is calculated by the pulse in function. So this duration is used to calculate the distance. We know the speed of ultrasonic waves in air, which is 343 meter per second. So that when we convert it to mm, it will be 0.034 meter per second. And the duration is for going and coming back. So it is twice the time taken. So we just divide it by 2. So that is what I wrote it here. And I'll just print the distance here. So let us see how this works. Okay, I'll show you my serial screen. Where is it? Serial monitor. See here, it's showing distance 110, 110, 110, right? Yeah, the distance covered. So I'll change the distance. See, it is changing. So I'm changing the distance. It's going like that, like that. So it is taking from trigger pin. I'm sending an output to this point at some 10 seconds of wave, which is getting reflected back and is received by the echo pin. There is a time calculated between the difference from how much time it has took to reflect back. That time we divide it by 2 because it is going there and coming back. We just require how much the distance, one distance is enough. Like we don't need the going back and coming back distance. We just need how much time it is taking, how much distance it is away. So that's just basic common sense. And we use just basic kinematic here. That is calculating distance from given speed and time. So that's it, guys. This is how we use an ultrasonic sensor. I want you guys to try out an obstacle detection light. Like I have a light after, I need you to use a if condition to generate an LED output. If my output is crossing around 150, I want an LED to blink. If it is inside 150, I need my LED to stop. Like that. Someone can code it and just let me know in the LinkedIn. So that's the official end of the session. Yeah, that's what I meant, Abhijit. Yeah, it's correct. Detects sound which it emits and after it touches some surface. Yeah, it doesn't reflect back, it takes a lot of time, right? So it will be infinity, something like that. So it will be given random value, that is the highest value of the distance. Any more doubts? Just let me know now. Was this helpful? Anyone was able to get some input from this? If so, just let me know.